So we ended last meeting here with fixed bias configuration with this example, right? And ang atong set work or activity is that we do all of this with beta is equal to 100, right? So while waiting for the others, let's try to answer this one. Ito lang i-fast track of answer with beta is equal to 100. So for each case, or for any case, whether beta is 50 or 100, I think IB will still be 47.1 microamperes. If you look at the equation, this one, it's not dependent man on beta. So for beta is equal to 100, IB will still be equal to 47.1 microamperes. So for IC, since beta is now 100 times 47.1 micro, IC is, if I'm not mistaken, 4.71. Okay. Good, no? So yeah, 4.71, of course. 4.71 milliamperes, making IE equal to, well, approximately yapon, but multiply na to 101 because 100 plus 1 man ang beta plus 1 man ang IE. So 4.76. Yeah, 76 milliamperes. So if atong i-solve ang percent difference, okay, so this is our IB, new IB, new IC, new IE, and percent difference for each current IC and IE will be equal to, so itong formula to, old minus new over old plus new times 200. So ang old is 2.35. So 2.35 minus 4.71. So 200 times minus or plus man ba. So 4.71 minus 2.35 divided by 4.71 plus 2.35 times 200 is equal to, so nasa mga 67% more or less. 67% difference. Considering that the difference of 100% difference man ba? Nag-jump man siya times 2. So 100% ang yung difference. So here, 67 ang sa IC. Diba? So for IE, 4.76 minus 2.39 over 4.76 plus 2.39. The percentage difference is the same yapon, no? 66.3 or more or less 67 yapon. So how about for VCE? So VCC, new VCE is equal to, so we'll still use this formula. VCC minus ICRC minus VCE, or 12 minus what's in the IC? 4.71 times 2.2. So then the VCE is 1.64. Okay, tayo sa 6.83. No? So we solve for the percent difference. 200 times 1.64 minus 6.83 or 1.64 plus 6.82. So nasa mga, ayun diba? Ayan, 123% difference. Okay. So, well, ang pinaka-important na parameter here for us, which will affect the load greatly, would be the voltage, VCE. Okay, sa diha mga terminal natin connect atong load. This load might be a speaker or another amplifier. Okay. So notice na ang pag-jump sa atong beta from 50 to 100. So having a difference of 100% would yield a 120% difference in VCE. So bako kayo. This makes fixed bias configuration very unstable to changes in beta. Okay. So for this afternoon, I'm going to introduce two other biasing configurations which are more stable compared to the fixed bias. So what are these? These are the emitter bias, the emitter bias configuration, and later the voltage divider bias. Okay. So the emitter bias configuration. So what is this? What's the difference niya sa form compared to the fixed bias configuration? Okay, so for the emitter bias, actually isa lang madungag na circuit element. We'll just add a resistor to the emitter terminal. If you could remember, unang itsura sa atong fixed bias configuration, right? VCC, RC, RB. This is our transistor, BJT, NPN, and connected to the ground. But for the emitter bias configuration, instead of the emitter terminal connected to the ground, we will add an emitter resistor, which we'll call RE. Yeah. So, mo lang, no? That's the only difference in terms of the form of the circuit when we compare the emitter bias to the fixed bias. But even if mo lang na siyang difference, this makes the emitter bias more stable. Than fixed bias. Due to variations in beta. Or temperature, or etc. Because temperature could also influence the value of beta. Okay, let's say, for example, the beta of this transistor is 50. But if the ambient temperature of the amplifier, kung asan siya nakasituate, is mo increase po ng beta. So sa atong design, we used a beta of 50. Pero sa actual, di na siya 50 kay mas init man na ang environment. So if mo increase ang beta, therefore mas mo increase ang current na mo flow through sa circuit, di na magka-dimaw atong design, no? So the same as how we designed it originally. So di siya stable. But if we'll use an emitter bias, more stable siya compared to the fixed bias, no? Mas actually pwede man ito ma-prove later. to example, makita nato nga mas stable gyud no ang emitter bias. So in terms of current, or I mean circuit na formulas, dili gyapon ta mag-derive. We'll derive one from the input na side or sa base na side, and we'll also derive one from the output na side, or sa collector na side. Yan na. So KVL to dito. And KVL punta sa other side. Kung KVL to speaker side, if you compare na to atong KVL equation from previous, this one, o mamaya itong KVL equation, notice this one. So sa fixed bias, it's VCC minus IBRB minus VBE. Actually, the same lang yun ang tsura, no, nalang na dungag. Ay, erase lang sa ako ni kayo. Tas manigamay. So if atong isubay, awak ka sa VCC minus VB or VRB or IBRB minus VBE, itong 0.7, and minus another variable, voltage across the RE. So i-incorporate sa equation. Our equation would look like this. So VCC minus IBRB minus VBE. Okay. Wala man ni ang katong sa fixed bias, but for the emitter bias, ito i-subtract na another parameter, IE RE 0. So this is our KVL equation from that side of the circuit, no? Sa left-hand side. So kung atong i-observe, kani given, RB is given, RE is given, VBE is constant 0.7. So natin do ka unknown, si IB ug IE. Right? It would be difficult if isa lang ato equation, or whether nata isa ka other equation but dili gyapon IB ug IE ang variables. So this would try solve. No? So this is not a two equation to unknown type of problem, but we'll try to invoke one of the fundamental na formulas sa atong BJT. Okay? That relates IB and IE. So asa man siya, 1, 2, 3, or 4. So it's formula number 4. Formula number 4 relates IE and IB. IE is equal to beta plus 1 IB. So ato to i-remember, because IE is equal to beta plus 1 IB. Pwede na to substitute ning equation dire. Thus, VCC minus IB RB minus VBE minus beta plus 1 IB times RE equal to 0. So this is our KVL equation from the left-hand side. May look intimidating kaya kay variables class, but notice isa lang ang unknown ani. VCC given, RB given, VBE 0.7, beta given, RE given. So one equation, one unknown. So masolve gyapon nato si IB. And based ato mga nanga-solve ng example, once IB is obtained, it's easy for us to solve for IC and IE. So ato lang makuha sa right-hand side sa equation is si VCE, which we also derive. KVL ta sa here. So VCC minus ICRC minus VCE minus IERE. And ang unknown lang here this time is CVCE. So again, ako to i-recall, VCC minus ICRC minus VCE minus IERE equal to 0. This one, si IERE, given may si RE, si IE na-solve na siya earlier. Si IC na-solve na po na siya earlier. Si RC given, VCC given. So, one equation, one unknown nagyapon. So, before I proceed, any questions? So, if there are none yet, ako may question. So, ang question ako is, sir, kinanglan ba ni memorize yung tanan? Right? Dagan mo ka equation. So, for the emitter bias na iduha ka bagong equation. So, fixed bias na po iduha ka equation. Do I need to memorize all of this? What did I say previously? As much as possible, kaning upat lang ang memorize nun ta. Kaya dali lang mo po sa memorize nun yun. IE equals, kanila ganing tulad, dapat, di ba? First three. IE equals IC plus IB, IC equals beta IB, BB equals 0.7. So what about the others? What about the KVL equations for fixed bias and emitter bias? So pwede na to dili memorize on if we have a copy of this table. So sa kaninga table, naka-summarize na ang mga KVL equations for fixed bias and emitter bias. So we could solve directly for IB and VCE for fixed bias. We could solve for IB for fixed bias. We could also solve for VCE for fixed bias. So, na, no? So the purpose akong gibuhat kanina is just for us to know giun sa ni pag-derive kaninga mga equation. But if kabulota, kung asang gigikan ng mga equation, these ones, this one, and this one, if na natay background, yung na ako na pag-derive, so pwede na ito technically delete na memorize so nga mga formula. Ato lang i-refer sa kaninga table 4.1. Now, don't worry, I'll provide a copy for this page. Pwede na ako ni-upload sa atong e-learn para na po may copy. And conveniently, pwede nyo ma-refer anytime. No? So as long as the given circuit is perfectly looks like this and this, meaning fixed bias and emitter bias respectively, pwede lang i-diretso o invoke ng mga equations without memorizing. Okay? Kuha to class. Hello, are you still there? Okay, thank you. Thank you, Danielle. So let's try to solve an example. Emitter bias configuration. So clearly this is an emitter bias configuration because aside sa RB and RC, dapat tayo isa ka resistor connected sa emitter, which is si RE. Okay. So I could use these formulas right here, kaning na newly derived na ko. This one and this one. Or if I could refer to the table, pwede po ka to. So let's learn daw this time how to use the table. Sige, so emitter bias man to, no? It's this one right here. So if you'll solve for IB and VCE, kani nga mga formula itong gamiton. IB and VCE. Wala. So VCC minus VBE over RB plus beta plus 1 RE. So kung lang siya memorize ka dyan. VCC minus VBE RB plus beta plus 1 RE. Same yapon, solve for IB, IC, IE, and VCE. Where beta is equal to 50. So from table 4.1, IB daw is equal to VCC minus VBE all over RB plus beta plus 1 RE. Okay. VCC, VBE, RB, beta plus 1 RE. Okay. So given na tanan. Given na siya tanan. So VCC is 20. If you have your calculators, 20 minus what's VBE? VBE is always equal to 0.7 volts. So 20 minus 0.7 divided by RB, which is 430K, plus beta is 50, so 51. RE is 1K. But to check my answer, if the same bata, it's 40.12 or 13 microamperes. 40.1 or 40.13 microamperes. So not to solve the IC and IE. IC is easily equal to beta IB. 50 times 40.13 micro is equal to 2.01 milliamperes. IE is beta plus 1 IB or 51 times 40.13 micro. Later it's 2.05. 0.1 plus 40 micro is 0.51. So 2.0 milliamperes. So IB, IC, IE, BCE na lang dayon. No? So same gapon. From table 4.1, VCE is equal to BCC minus IC. Approximate naman din, no? Sige, pwede naman ni. No? Pwede naman gid ni. Digamit niya ang approximation aning IC is approximately equal to IE. So, nakakuha siya yan ng formula. So, yeah. Sige lang, valid na siya. If gusto tayo mag-exact, mas exact yun, could use the formula that we have derived previously. We could use this one. We'll obtain a more exact na value. Pero, okay lang, no? Okay naman to, wala problema. So, VCC minus IC RC plus RE daw to. So, given naman ito naman. VCC is 20. 2.01 milli times how much is RC? 2 kilo, 1 kilo. It's 13.98. Approximately mga 14 na. 13.98 volts. Final answer. So before I proceed, any questions? Is it all clear? Okay, if any question, I'll proceed to the next one. So this was the emitter bias configuration. Another configuration which is more stable compared to the emitter bias. If you compare to the emitter bias and the fixed bias, stable na, no? Stable na already si emitter bias. But another configuration that is more stable compared to the emitter bias is the voltage divider bias configuration. Voltage divider bias configuration. Okay. So, sa itsura sa iyang circuit. Actually, man yung pinaka-common biasing configuration na ginagamit for BJT. So, man itong emitter bias, right? Kung i-compare na to sa voltage divider, ang nadungag lang yun is, again, another resistor that is connected in parallel to the other resistor at the base. So we have our source, VCC, resistor RC, resistor RE. So, and base resistors RB1 and RB2. RB1 and RB2. Now, in terms of circuit analysis, medyo complicated ni. Di man yun difficult actually. More complex lang siya compared to the emitter bias. Pero dili siya naka-difficult if we'll convert this one into something that looks like an emitter bias configuration. So it will be difficult for us to derive the KVL equations if nakaingani pa siya nga form. So we'll convert this one into something that we can comprehend, no? So ato lang i-kuan, no? I-simplify. Okay, simplify na to. Instead of ingani, our circuit will look like an emitter bias. Nagyapon tayo transistor. Now, instead of duha ka resistor sa base, let's convert this one as if isa na lang kabuok. No? Let's call this new resistor as RTH. Now, instead of VCC, i-connect na to sa atong new RB or RTH. We'll have a new voltage source that we'll call, sometimes it's called VTH. Pero para uniform sa atong table na gamiton, we'll call this one ETH. This voltage source, we call this one ETH. Sa output na side or sa collector emitter na side, parehara. This is still RE. This is still RC. This is still VCC. So we've converted our voltage divider bias configuration into an emitter bias configuration. Emitter bias magyapon eh. No? Isa lamang ka RB, isa ka RC, isa ka RE. So if atong i-derive ta isa ka KVL dire. So derive po ta isa ka KVL dito. Because we'd end up with the same formulas we had previously sa emitter bias. But first, we'll define RTH and ETH. So after na to ma-define si RTH ug ETH, pwede na to butang ang asterisk here, return to emitter bias na analysis. So let's define first RTH. So RTH is equal to RB1 parallel RB2. Nakadundom ta sa atong circuits, no? Or high school na electricity. Sa itsura na basta na parallel nga kuan configuration 1 over 1 over RB1 plus 1 over RB2. Diba? Yan na itsura, diba? For parallel na circuits. For ETH, it's just the voltage divider na formula. So it's VCC. It's supposed to be R2 over R1 plus R2. Diba? Yan naman ang formula sa voltage divider. But instead of R2 and R1, it's RB2 and RB1. So RB2 all over RB1 plus RB2. Now, why TH? Why ETH and RTH? Because this is the product of using Thevenin equivalent circuit. After performing Thevenin analysis, for which di na nato usbon, medyo taas-taas naman good, we'll just leave this as is, as if naka-perform good the actual nga Thevenin analysis. So, tungkol kay, if kadungdong mo sa inyong circuits 1, diba? Medyo lisod siya. Libog. So, di na lang ito nato usbon gyud ang Thevenin nga equivalent circuit na analysis. We'll just state this as is na morning formula for RTH and ETH. So we have the Thevenin voltage and Thevenin resistance here sa input sides equation. So this is our voltage divider bias configuration. Actually, paday tanaw man, no? Kuan paday ni ato palang gi-define si RTH and ETH. So kung balik ta sa atong KVL na analysis, KVL ta dito nga side, it's ETH minus IB RTH minus VBE minus IE RE. Yet we know that IE is beta plus 1 IB. If mag-Thevenin po ta sa input side sa circuit, sorry, KVL. KVL po ta sa input side sa circuit, the same siya sa emitter bias. VCC minus ICRC minus VCE minus IERE equal to 0. Yan na. So these are the formulas for the voltage divider bias configuration, of which naagapon sa atong summary table 4.1 nala. Sa pinaka-bottom sa screen. So we have two sets of equation using an exact one and an approximate one. So practically, we could use now the approximate set of equations if this condition is satisfied. When beta times RE should be greater than or equal to 10 times R2 or RB2. Okay. But if dili, or if we'd want a more exact na analysis, but for us, I'd really recommend using the exact na analysis. Later lang siguro approximate kung if there are parameters that are hard to obtain. So we'll use the approximate one. So dili kay nato may i-advise og gamiton if pwede man lang tamang exact, even if this is satisfied. Okay? So we'll use the exact na analysis. Notice, the same sa mga formulas na ito na derive. RTH, ETH, IB, and VCE. Pareha lang. Diba? So starting very soon, try to learn how to use our table 4.1. Very convenient. At least yun ito mag-memorize. Okay, dagan pa dire, no? Dagan pa sa silong. Collector feedback, emitter follower, common base. But we'll not anymore derive each one of these, especially sa last three, because kabalo naman taon sa pag-derive. No? Ato lang i-compare if ang given na circuit is naaba aning mga remade na configurations, especially if na siya sa any of these six one site here. Okay. So, mo man ba voltage divider? Before we no, maybe before we end, let's try to solve another example. That's voltage divider bias configuration. So same nga po, solve for IB, IC, IE, and VCE. So itong given na ito. Okay. VCC daw is 22 volts. Uh, 10K, 1.5K, 39K, and 3.9K. Where beta is equal to 100 this time. Okay. So, muna yung atong given circuit. So, the same with the previous example, we could invoke easily table 4.1. From table 4.1, RTH is equal to RB1 parallel RB2. So it's 1 over 39K plus 1 over 3.9K. So RTH is equal to 3.545K. Same gapon from table 4.1, ETH is equal to VCC RB2 over RB1 plus RB2. VCC is 22 times 3.9K over 2.9 that's 39. 22 times 3.9 over 3.9 plus 39. 2 volts. So tayo RTH and ETH. Same yapon from table 4.1. We could solve for IB. IB is ETH minus BBE, RTH plus beta plus 1 RE. Ang slight similarity sa IB, pag-obtain sa IB sa emitter bias. So, ETH minus BBE all over RTH plus 1 RE. 2 minus 0.7 all over 3.54K plus 101, which is RE, 1.5K. I'm not mistaken, it's 8.38 microamperes. Microamperes. So if ma-obtain na si IB, it's easy for us to obtain IC and IE. IC is beta times IB, 8.38 micro. Ulit tayo. 100. So 0.838. 0.838 milliamperes. IE is 101 times 8.38 micro. So 847. 847. 0.847 milliamperes. So that's IE and IC and IE. Last, solve for BCE. Again, from table 4.1 gihapon. This one, BCC minus IC, RC plus RE. So, BCE, so BCC minus IC, RC plus RE. So, BCE is equal to 22. Dito na ito, no? 22 minus 0.838. 10 plus 1.5. So RC is 10. K plus RE is 1.5. 1.5. BCE minus 0.838 times 11.5. 12.36. 363. 12.36 volts. 12.36 volts. Final answer. All right. Any questions? Kaya ba? What do you think, class? Kaya ba ang procedure?